In this video we will talk about why one may choose to use machine learning. Traditional programming is already quite difficult, but of course machine learning can be even more challenging to use in many cases. So why would you? First, let's define what machine learning is. In the 50s, Arthur Samuel defined it to be the field of study that gives computers the ability to learn without being explicitly programmed. So when would you want to use machine learning? Well, whenever we want to let the computer do something without explicitly writing the code that explains how one should do it. Let's have a look at a familiar example. This is a picture of my inbox with, as you can see, many spam messages. How would you go about designing a spam filter? Let us discuss the traditional programming approach and the machine learning way to contrast the two. Let us start with the programming approach. First, you would start looking at some emails to get an idea of what spam and normal emails look like. Then you will try to come up with all kinds of rules to build the spam filter. You will write some code to implement those rules. Finally, you would evaluate your programmed rules on some emails. You will see how well your spam filter works, how many spam mails are detected, and how many unwanted messages can sneak through it. You will most likely find that writing a good solution is quite difficult. You will have to look at the errors made by your rules, so you can further try to improve your rules. You will probably go through this process multiple times to improve your rules further and further. After several tries, the programmed filter will hopefully work well enough and you consider the task to be done. Okay, so this was the programming approach. Now, what are the downsides of this approach? First, let's start with the code. In the top right corner of the slide, I have some code for our potential spam filter. If the subject contains a $sign, then the email should be considered as spam. But if it instead contains the word bank, then it probably is an important message, etc., etc. What you see is that the code contains many rules in the form of if statements. There are also many exceptions. Sure, we can write this kind of code, but including all possible cases can be quite difficult and painful and time-consuming to implement. Furthermore, the spammer will probably notice that by changing the text slightly, they can get through the filter. For example, they may change the wording of "for you" as indicated in the slide. Thus, it becomes a cat and mouse game, where you may need to go back to your code many times, maybe every month or every week, to update it. This is a very time-consuming and difficult task. Why? Well, because updating code, as you will find, is even more difficult than writing new code. Now let's see how a machine learning approach would tackle this problem of spam filtering. For the machine learning approach, we would start by studying the problem and collecting a lot of data in the form of spam and non-spam emails. You will also have to formulate this problem as a machine learning problem and choose the right kind of machine learning algorithm. After that, you can use the machine learning algorithm to train a model. This model can be used to predict whether an email is spam or not. After training your model, you will probably again want to evaluate its performance. You will do this by checking how many spam messages are detected correctly by the model and how many sneak through. Just like in the programming approach, you will likely need to go back into a loop. Machine learning is not guaranteed to work perfectly the first time. You will probably have to do some fine-tuning until your machine learning algorithm works as desired. Hopefully, after some tries, we are happy with our results and we are done. So why would we prefer machine learning? Well, first of all, machine learning algorithms can discover rules quite efficiently. In many cases, training or retraining the model is very fast, a matter of seconds. And often the rules found by a machine learning algorithm are next to impossible to be made up by a human. Also, you would have to make a very long list of rules with many exceptions. We don't know as humans how to do that efficiently, while the machine can. Machine learning algorithms can find solutions even for very complex problems such as speech recognition, image recognition, bioinformatics, etc. For many of such problems, we don't even know how to write the code ourselves to solve these tasks. So, in fact, we can learn from our machine learning algorithms. A second advantage is that the machine learning code will usually be much simpler. Instead of a list of hundreds or thousands of rules, we can build a spam filter with just a couple of lines of code. This is much easier to deal with. Finally, if we gather some new data, we can easily plug it into the system and retrain the machine learning model. Thus we can update our filter at any time if we have new data. In the programming approach, we would need to revise our long list of rules by hand, which is much harder. Nonetheless, there is one major disadvantage of the machine learning approach. You need data of sufficiently high quality and usually lots of it. In the programming approach, you don't always need data. For instance, you can think of spam rules without looking at any emails. Alright, let's summarize this video. Why do we want to use machine learning? Well, because many problems require complex systems of rules. In such cases, machine learning can simplify code and increase performance. It is also much faster to build such systems of rules with machine learning. Moreover, machine learning can solve problems for which we don't even know how to solve them. In such cases, we can learn from the machine. We have also seen that if the environment changes over time, we can easily retrain the machine learning algorithm. In contrast with the programming approach, where we have to manually update our rules by hand. At the same time, we have observed one major downside of machine learning, and that is that we need a lot of data.